Hello, 1030. This is your video notes for your 1B propositions and truth tables. A proposition makes a claim, either an assertion or a denial, that may be either true or false. It must have the structure of a complete sentence. So any proposition has two possible truth value. Has two possible truth values, either true or false. A truth table is a table with a row for each possible set of truth values for the propositions being considered. A negation, the negation of a proposition P is another proposition that makes the opposite claim of P. So if our proposition is Amanda is the fastest runner on the team, the negation would be Amanda is not the fastest runner on the team. This is a truth table showing all the possible truth value combinations for a statement and its negation. If P is true, not P would be false. If P is false, not P would be true. We have a double negation. The double negation not P has the same truth value as P. So if P is true, not P right there, I shouldn't draw that arrow because that implies something else, then not P is false, and not P then becomes true again. If P is false, then not P becomes true, and not P becomes false. Here we have the statement. It says it's true. I don't think math is not fun. Do you think math is fun or not? Well, we've got this double negation, so it cancels that out. So do we think math is fun? Yes. I hope you think math is fun. Logical connectors. These are propositions, propositions are often joined into more complicated propositions using what we call logical connectors. And these are words such as and, or, and if then. So for example, P, I won the game. Q, it was fun. So our logical connector for that we're going to use is and. Sorry, the formatting is a little off on this. The new proposition, I won the game and it was fun. Symbolically, we use that symbol to represent and. So we would say P and Q if that's P and that's Q. We have or, I won the game, so P is I won the game, or it was fun, or has that symbol there, looks like a V. Or I could have an if then, and if then is our logical connector. If, here's P, I won the game, then it was fun, there's Q, and we would say if P, then Q, and that's what it symbolically would look like. Or, yes. Okay, we have and statements. These are called conjunctions. Given two propositions, the statement P and Q is known as a conjunction. This is really important that you understand this piece. It is true only if P and Q are both true. And again, there's our symbol. So it's only true if P and Q are true. Well, here I have P is true, Q is true, then P and Q is true. It's only true if they're both true. So the rest, if P is true, Q is false, this is false. If P is false, Q is true, this is false, and they're both false, so it has to be false. So you really want to pay attention to your connectors. So for example, this says evaluate the truth value of the following two statements. It says the capital of France is Paris and Antarctica is cold. So for an and statement to be true, they both have to be true. So is the capital of Paris France? Yes. Is Antarctica cold? Yes. So because they're both true, our statement is true. On B, the capital of France is Paris and the capital of America is Madrid. So we know that this first one's true. Now, is the capital of America Madrid? No. So because one of these is false, or both of them, but in this case only one of them, then this statement would be considered false. So to be true, they both have to be true. We have two types of or. We have what's called an inclusive or. It means, I like to think of it as one or the other or both. And exclusive means one or the other, but not both. So in our example of inclusive, an insurance policy covers hospitalizations in cases of injury or illness. So it could be injury or illness or both. And exclusive, here we have a restaurant offers a choice of soup or salad. So you can only get one or the other. You can't get both. So that would be exclusive. So here, given two propositions, the statement P or Q is called a disjunction. Now this is really important here. It is true unless P and Q are both false, and there's your symbol. So it's true unless P and Q are both false. So that means if P is true, Q is true, this is true. If P is true and F is false, this is true. If P is false and T is true, this is true. If they're both false, it's false. So example 4, here's our proposition. Airplanes can fly or cows can read. So airplanes can fly. Yes, that's true. Cows can read. No, that's not true, but the overall statement, because it's an or, is true. To not be true, they would have to both be false. Okay, my symbol somehow ended up over there. It should be right here. That's my symbol for an if-then statement. These are called conditional statements, or a conditional proposition. It is true unless P is true and Q is false. The proposition P is called the hypothesis. The proposition Q is called the conclusion. So keep in mind, it is true unless P is true and Q is false. So here on our truth table, if P then Q, we've got P is true, Q is true, so it's true. Here is that case. P is true and Q is false, so this is false. On our next one, P is false, Q is true, so it's true, and false, false still gives us a true statement. These are just some alternative phrases of conditionals. You could use these words. It still means if P then Q. So if you have P is sufficient for Q, Q is necessary for P, P will lead to Q, Q if P, P implies Q, or Q whenever P. Those are all alternate ways or phrasings that you could use as a conditional statement. So here in example 5, evaluate the truth value of the following statements. Now, remember this right here. If P is true and Q is false, then your statement would be false. So if 2 times 3 equals 6, so that's true, then 2 plus 3 equals 6. Well, 2 plus 3 does not equal 6, so that's false. So here you go, you have that case with an if-then. If P is true and Q is false, then your statement is false. Our next one says, if dogs can swim, can dogs swim? Yes. Then dogs are fish. Are dogs fish? No. So again, our truth value of the statement would be false. Now the next one says, if dogs are fish, are dogs fish? No. But if they were, then dogs can swim, which is true. Dogs can swim. So this has an overall truth value of being true. With conditionals, the order of the proposition matters. So you notice that I switched these two, and by switching it, we took a false statement and made it true. So just be careful with conditionals. By switching them, we can change its truth value. This is it for this lesson, so good luck with your assignment on MyMathLab.